Hello all, welcome back to Pure Learning. So till now, let me give a small recap. Okay, in our first video, we started seeing about algebraic methods which are used in solving a pair of linear equation in two variables. Okay, what did we do next? Elimination method. First we did substitution method, then elimination method, then cross multiplication method, and then we came to the graphical method. And after that we started with our first exercise in the NCERT textbook, exercise 3.1, and we solved the three problems in our previous three videos, right? Now in this video there is something important which needs to be discussed. Okay, what is it about? Okay, now let's say there is a particular pair of linear equations. Okay, linear equation in two variables. Say I am writing 2x plus 3y is equal to say 10, and 4x plus 3y is equal to 9. Okay. So this is a pair of linear equations which I came up with just right now. It's a random equation. But how can we find whether this pair of linear equation has a unique solution or infinitely many solutions or no solution? This is the thing. So whenever a pair of linear equation is given, by comparing, or rather by, there is this particular relation where we need to consider the coefficients and see whether this relationship exists. Okay, what is that relationship? Now, I have 2x plus 3y is equal to 10, 4x plus 3y is equal to 9. Okay, now this is A1, this is B1, this is C1, this is A2, this is B2, this is C2. How do I write this A1, B1 and all? We know the general form of a pair of linear equation. General form of a linear equation, right? Ax plus by plus c. Since we have two equations here, I am taking A1, A2, B1, B2 and C1, C2. Now, the first thing which we need to do is take A1 by A2 and B1 by B2. Okay. Here I am taking A1 by A2, which is 2 by 4. And here B1 by B2 is 3 by 3. Okay. So 1 by 2 and here we have 1. So these two are not equal, right? Which means that this particular pair of linear equation has one unique solution. That is, when we actually plot these two equations in the graph, when we get two lines, they will actually intersect in one particular point. So the relation is, when A1 by B2 is not equal to B1 by B2, the pair of linear equation will have one unique solution. Okay. Now, another example. Let me take a different kind of equation. 2x plus y is equal to 3. I am taking 4x plus 2y is equal to 6. Okay. Now, what do you observe in this particular equation? When we multiply this whole equation into 2, we are actually getting this, right? Okay, what does that mean? That means that both these lines are just the same, right? When whatever x and y value I get for this particular equation, the same x and y value will apply for this equation also. That is how it is. Say here I am giving 2. If I am giving 2 here, and y I am giving minus 1, right? If x is 2, y should be minus 1, so that we get value of 3. Even if here, if I give the same value, x is equal to 2, y equal to minus 1, we get 6. Whatever value satisfies this particular equation also satisfies this particular equation, both these equations. That is, when we get A1, in this case A1 by A2, I am taking B1 by B2, C1 by C2. Okay. Here we have 1 by 2, this is 1 by 2, this is 1 by 2. Here in this case, A1 by A2 is equal to B1 by B2 is equal to C1 by C2, which means that it has infinitely many solutions. That is, it's just that both these lines are the same. Both these lines are the same. I get 2 comma minus 1 is a value for this one, 2 comma minus 1 is a value for that also. Let's take something else. 1 comma 1. Here also it will come 1 comma 1. So A1 by A2 equal to B1 by B2 equal to C1 by C2 will say that this pair of linear equations has infinitely many solutions because both these lines exactly lie on each other. Lines exactly lie on each other. That is, they just coincide. Okay? This is what it means for infinitely many solutions. Now what does it mean for no solutions? Okay. We'll have, when will we get no solution for a given pair of linear equations? Okay. So whatever it is, when we find the solution for a particular graphical method, what we do in graphical method we see if they intersect, right? We draw the path, and whenever they intersect, that is when we can say that the pair of linear equation has a solution. Okay. When will two lines not intersect? When will two lines not intersect? Two lines will not intersect when they are parallel, right? When they are parallel, however infinite distance both these lines goes, they are not going to intersect at all. That is what is the case here. Okay. How do we find whether this particular pair of linear equation is a pair of parallel lines or intersecting lines? Okay. So let me give another equation. Say I have x minus 4y is equal to 7 and 2x minus 8y is equal to 10. Okay. This is the pair of linear equation. How? That is this particular relation. Pair of linear equation which has no solution. And the criteria for that is, let me say, here I am taking A1 by B1, sorry, A1 by A2, B1 by B2 and C1 by C2. Okay. Now I have A1 by A2 is 1 by 2, this is also 1 by 2. I have A1 by A2 is equal to B1 by B2, but B1 by B2 or A1 by A2 is not equal to C1 by C2 because this is not giving me 1 by 2, right? So this is not equal to C1 by C2. When this is the particular case, they are not intersecting or they are coinciding. They are parallel lines, which means that it has no solution. That is the meaning for this. Understood? So this is very very useful for us to find whether a particular pair of linear equations has one solution or infinitely many solutions or no solution. That is what it means. So in short, let me just give the gist here. So I'm gonna write here, if the lines have one solution, exactly one solution. One solution means A1 by A2 not equal to B1 by B2. Infinite. And what does this mean? This is called consistent pair of linear equation. Consistent pair of linear. Now, infinitely many solutions. Which this is A1 by A2 equal to B1 by B2 equal to C1 by C2. Now, the next one is no solution. For no solution, it is, you guys know it, right? A1 by, I have written it above. A1 by A2 equal to B1 by B2 not equal to C1 by C2. Okay, and this one is called inconsistent. Sorry, this one is inconsistent. This one is inconsistent and this one is dependent. So if they give you a pair of linear equations and asks you whether it is a consistent or inconsistent or dependent, what you need to do is, if you want to check whether it's consistent, you need to check this one. You need to check whether a1 by a2 is not equal to b1 by. You don't have to solve the pair of linear equations and find that there is no solution and everything. That is not necessary. If you look at the coefficients, just compare the coefficients using this relation. If this satisfies, if a1 by a2 is not equal to b1 by b2, it is a consistent pair of linear equations and it has exactly one solution. Okay. Now, if it has infinitely many solutions, it is called a dependent pair of linear equations, and a1 by a2 will be equal to b1 by b2 and that will be equal to c1 c2, which means that two lines are exactly coinciding. That is what it means. Now, when a1 by a2 is equal to b1 by b2 but not equal to c1 by c2, in this case, where we'll be getting a parallel lines, and these parallel lines won't intersect anywhere, which means that there is no solution, right? Since there is no solution, these are called inconsistent pair of linear equations in two variables. Understood? So this is very important in, or rather critical in looking at a particular pair of linear equations and saying how they are going to be. Like, so you are, say you are going to write an exam, right? When you are writing an exam, you see your paper and you have a pair of linear equations. So how do you find whether they will have one solution or infinitely many solutions or no solution? You just use this relationship. That's it. You don't have to solve at all. This is like very, very useful for you to say about a particular pair of linear equations just by looking at it, right? It's going to be very simple. It's going to consume very less time, and you're going to be very quick in finding about the pair of linear equations. That is what this is about. Understood? So this is very, very important, and there will be very, very important many questions about this in your exams, right? Yeah, these are very, very important. Understood? So yeah, we have understood this one. We will see the next exercise in this particular chapter in our next video. Okay, have a good look. I might be shabby here. I'm really sorry for that, guys. I just wanted to be the explanation much better. Okay.